we will discuss about the weld metal transfer modes. As I told you, in case of fusion welded joints, we use some external electrode to fill the gap between the workpiece to provide the sufficient weld metal between the workpieces to be joined. So the question arises how the material of the weld metal is transferred into the welding zone. Based upon observations and some experimental conditions, scientists have categorized this weld metal transfer mode into four different categories. One is the short circuit transfer mode, other is the globular transfer mode, then third one is the spray transfer mode, and we have an advanced transfer mode which is known as the pulse spray transfer mode. Short circuiting transfer mode you might have seen in your welding practical, where you used to touch the electrode over the workpiece surface, and due to the short circuiting current it leads to the melting of your electrode and the workpiece. The same concept is utilized in the short circuiting transfer mode. The frequency of oscillation of your welding electrode which is going to touch on the surface is controlled with the help of a very sophisticated instrument, and we have a different type of the gun or the torch which controls the movement of the wire coming out from the nozzle. You have to decide the frequency of short circuiting in this welding process. This mode of transfer can be used for welding all the positions and also utilized for welding of sheets of various thicknesses. Then we have this globular transfer mode, in which you can observe big drops coming out from the melted tip of your electrode, and then it is creating the weld pool, big size weld pool. This is your globular transfer mode, in which the big droplets are developing on the tip of your melting electrode, and then it is detaching from the surface one by one. Then we have the spray transfer mode, in which you observe the spray, the jet of the molten droplets coming out from the melted tip of your electrode, and then it is penetrating deep into the workpiece. So you observe that in case of globular transfer mode, a weld pool is somewhat wider and bigger, whereas in case of spray transfer mode, you can observe that you can get deeper penetration in the welding. Now we'll discuss how the droplets are generated. Whenever you apply the current and the potential difference between your electrode and workpiece, the gap between the electrode and the workpiece is ionized. Arc is generated. So due to the generation of this arc, melting of your workpiece and electrode happens simultaneously. At the same moment, this type of electromagnetic force, which is called the Lorentz force, is acting on the conductor, which is your electrode. This force will try to compress this conductor. Your electrode is solid up to this section. However, at this particular tip portion where the melting of your material is taking place, your electromagnetic force is much more dominating as compared to the solid wire, which helps in the compression of your liquid droplets at this section. It causes a pinching effect, which helps in the detaching of the molten material droplet from the tip of your electrode. Okay, and when there is a creation of the droplet at the electrode tip, so at that time the surface tension will act on the periphery of the droplets, which basically creates a resistance in the detachment or the creation of the droplets at the surface of the electrode tip. Okay, and at the same time gravity is also acting on the droplet. This pinching effect will cause the cutting or detaching of the droplet from the electrode tip. During the detachment, this particular molten droplets, it travels into this ionization gap. Gravity is also acting downwards. You know that this plasma or this arc is a very high temperature, which causes the certain portion of your molten droplets to vaporize. And due to the vaporization, a reverse pressure is creating in this particular section, which causes the backlash force or backward force on this droplet. You have different forces acting on this developing droplet, in which the gravity force is acting downward and this pinching force is working in this direction. It is trying to pinch the molten droplet, and it helps in the detachment of a droplet from the electrode tip. And this surface tension is creating the obstruction in the the creation of your molten droplet at the electrode tip. Now if you see in this diagram that this is a graph between your welding current and the rate of transfer of droplets per second, you see that at very low current, so up to 200 or 250 of the welding current, which type of phenomena is dominant. So you see that the short circuiting and globular mode transfer mode is activated, and you see that here the rate of transfer or the creation of the droplets is very less. But as soon as you increase your welding current up to 250 ampere, there is a abrupt change in the transfer rate of your droplets, which is developing at the surface of your electrode tip. After that, from 300 ampere to more than 600 ampere. So this 600 ampere is extremely very, and it results in the increased transfer rate or creation of droplets per second. And this diagram you can see that by increasing the drop volume, means the volume or size of your droplets which is developing at the tip of your electrode, it is getting reduced. And in this particular section you see in between 250 to 300 ampere, there is a transition of this Weld Metal Transfer Mode. And after this 300 ampere current, you have a spray type of Weld Metal Transfer Mode, because whenever you increase this current, this particular channel becomes more energized and more heating will be produced at the electrode tip, and simultaneously this effect will also increase. More dominating pinching effect at this particular section, which helps in the rapid attachment of the molten droplets. If you increase the current, then it will result in the high heat to the welding zone, which is also not desirable, because if you increase the amount of heat in the welding process, it will result in more metallurgical transformation, and also it will result in the setting up of stresses in the welded section. You have to take care of heat generation in the welding process, continuously supplying heat in this spray transfer mode due to the increased amount of current, which will increase the weld pool size, and it will also increase the heat transfer, more heat input into the welded section, which will result in the distortion and setting up of residual stresses in the material, may also result in the development of porosity inside the welded portion. Such type of problems can be taken care with the help of new transfer mode, which is known as the pulse spray transfer mode, in which the current is supplied in the form of pulses. In spray transfer mode, you are continuously applying the high amount of current, which will result in the bigger size of the weld pool, and such type of problems, more amount of porosity, more distortion, and more residual stresses will be observed in the welded section. There is no need to supply such amount of heat in the welding current. Once the droplet has formed, you don't require that amount of current when the droplet has developed and it is reaching to the molten weld pool. At this point, your current should come that level where you have only the sustained arc. You come to that particular level of current where there is a sufficient amount of energy to sustain your welding current, so that your welding will not be interrupted. This current reaches the maximum value, so this cycle goes on, and you are supplying the pulse in the form of pulses in order to regulate the heat input into the welded zone. This is a kind of pulse transfer mode. If you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.